Hi all, and welcome to this new tutorial series to create a neural network in JavaScript, which we will hopefully use to automate the game Asteroids. Now, we made this game Asteroids in another tutorial series, so feel free to check that out. You can download the code from the links below. There should be a sounds folder and an HTML file. So let's open the game up. So there's a triangular ship that can be moved around the screen, and it can shoot the asteroids. I'll just mute that. So the goal of this tutorial series is a very simple one, and intentionally so, because neural networks can be quite challenging. The goal is to rotate towards the closest asteroid and shoot. Rotate to the next closest asteroid and shoot. It's not going to be an algorithm. We're going to train a neural network to do this. So what is a neural network? Well, here it is. Basically, they're made up of a number of layers, so an input layer, a hidden layer, and an output layer. You can have multiple hidden layers, but we'll focus on just having a single hidden layer to keep things simple. Now, the input layer, it will take our game information, so we could pass things such as the angle to the nearest asteroid, or the current angle of the ship. The hidden layer is more like a processing layer, I guess. And the output, well, we'll probably have a single output, whether to turn left or turn right. So that'll be a single boolean. So 0 will mean left, 1 will mean right. We'll keep things nice and simple because these things can be quite complicated. In between each of these layers, there's a whole bunch of black arrows. Now, each of these black arrows represent a weight between -1 and 1, I believe. So for each neuron in the previous layer, it sends out information to each of the neurons in the next layer. So ultimately, we'll be sending in some training data, for example, the asteroid position and the ship's current angle or something similar, and we'll feed that through with an expected output, so either to turn left or turn right. Now, if it gets it wrong, we'll send that information back to the input, I guess, and use that to correct these weights. So ultimately we'll be sending in thousands of points of information, correcting these weights until finally we have a unique set of weights that can take any of our game information and give us an accurate and reliable output. So here's the position of an asteroid. What do I do? Turn left. Here's another position of a different asteroid. What do I do? Turn right. Let's just close that down. We'll have to create a new JavaScript file, just a plain text document called, say, neural network, and give that the JS extension. Yes, and open both of those in your favorite editor. I'm using Visual Studio Code here. So the first thing we should do is set up a flag to let us know that automation is on. So currently we have a whole bunch of flags in here. How about we pull them out? And we'll put them in a different section just to make it a little bit tidier. How about developer flags? Paste them in there. Sorry, just doing some housekeeping. So let's create a new constant called automation. Automation on. We'll set that to true initially. So when the automation is on, we'll want to set up our neural network. So just after we set up the game parameters here, so after new game here, set up the neural network. So if automation is on, let's leave ourselves a to-do here because we can't do it at the moment. To-do neural network. Good. Now also when the automation is on, we don't want the player to be able to control the ship, do we? So down in our key press functions, so key down, yep, here we go, key down and key up. So if the ship is dead or automation is on, return, don't do anything. So they can press the keys as much as they like, nothing will happen. Similarly in the key up method, if ship is dead or automation is on, return. We'll let the computer control the ship. Speaking of computers controlling ships, let's head down to the update function. That's where all the objects are drawn and moved and so on. So just at the start of the update function, just up near here somewhere, how about we say use the neural network to control, to rotate the ship and shoot. And shoot. So again, we'll just leave ourselves, so if automation is on, we'll leave ourselves a to-do here. To-do, control ship. Okay, good. Let's just make sure that we haven't broken anything. So head up the top. First of all, let's try it with the automation flag on. Okay, so I'm moving the arrow keys, I'm pushing the spacebar, nothing's happened. And just to make sure that we haven't broken anything, let's set it to false. Yeah, I can control the ship in that situation. So when it's turned on, when it's true, I've lost control of the ship. Awesome. Now head over to our new file, neural-network.js. At the top of that file, let's use a flag, use strict. Now what use strict does, it basically enforces good coding practice, things like you must declare variables and so on. We're also going to focus on ES6 JavaScript. Now ES6 is like the latest major revision to JavaScript syntax, things like class and constructors and so on. So we're going to use that, we'll try to use that throughout this tutorial series. Now neural networks use a lot of maths, specifically matrix maths. So how about we create a heading here called matrix functions. A matrix is essentially just a two-dimensional array. So it has a number of rows and a number of columns. So I'm just making this stand out a little bit. Matrix functions. There we go. So how can we represent a matrix? Well, how about we represent it as a class? So class matrix, give it a constructor. The constructor will take a number of rows and a number of columns. And how about optionally, we'll have data here as well. So if we put an equal sign here, it's a default value. So by default, it will be an empty array. So inside the constructor, let's set the variables. Now usually private variables, private instance variables are prefixed with an underscore, so we'll follow that convention. Do the same sort of thing for the columns and the data. Cols and data. Now to access those variables, we should put some getters. So just get rows. And all that does is return this dot underscore rows, and do a similar thing for each of the other variables. So cols, data, this cols and this data. So to use that, when we declare an instance of this matrix, we'd go matrix.rows, and that would return this dot rows. So inside the constructor, let's initialize with zeros. Initialize with zeros if no data provided. So if data equals null, somebody could pass null, couldn't they? Or data.length equals 0. So in the default case, that's true. If either of those things occur, then we want to populate this.data. This data will equal a new empty array. Now we'll have to loop through each of the rows. So for let I equals 0, so let is one of these new ES6 words. Basically, it means that I is only visible within the for loop. Let I equals 0. I is less than this rows, I++, lowercase I++. We'll want to initialize the row. So this data I will equal an empty array. And we'll loop through each of the columns. So let j equals 0. J is less than this cols. J++. This data ij, so we'll set each of the elements to equal 0. Good. If data is passed, we'll probably want to check its integrity. For example, somebody could put 3 rows, 3 columns, but provide data with only 2 rows. So that's not good, is it? So let's put an else here. Else will check data integrity. So if the data's length doesn't equal the row number, doesn't equal rows, or data, maybe data 0.length, so that's the column length, isn't it, doesn't equal cols, then let's throw a new error. So throw new error. Now the error takes a message. You can just put something like incorrect data dimensions. That should be enough. So let's test this. Let's go back to our main file. We'll have to import that file, so we can do that up in the style script. Create script tags, so script, and we'll need a type. Type will equal text, JavaScript, and the source will equal dot slash, that means the current directory, neural network, whatever we named our file, neural-network.js. Close the script tags. So head down to where we will initialize or set up our neural network, just in here. Let's try to set up some matrices. So let M0 equal new matrix, rows, say 2 rows, 3 columns, and let's output that to make sure that it's working. We could probably use the table command here, because it outputs table data, tabular data. So m0.data, that's the data of our matrix. Let's take a look at that. Just need to open the console. Here we go. We have a 2 by 3 matrix full of zeros. That's good. Let's try to pass some data. So we can do that by setting up an array here. So an array of arrays, I should say. So 2, 1, just add in some values here. And the next row, 4, 3, 4, 3, 0, say. Okay, let's give that a go. There we go. 2, 1, minus 1, 4, 3, 0. 2, 1, minus 1, 4, 3, 0. Now what if we declared the incorrect dimension here? Just so we said a 3 by 3 matrix instead of a 2 by 3. Let's check our error checking. Good. Error, incorrect data dimensions. Put that back. 2. Awesome. Head to our other file to create another function. So let's create a function that randomizes the weights, or creates a random set of weights. Remember, between our neurons, there's going to be some weights between -1 and 1. So let's create a function for that. So apply random weights between -1 and 1. So we'll call this random weights. So this is inside our class. For let I equal 0, I is less than this dot rows, I plus plus. For the columns, for let j equal 0, j is less than this dot columns, j plus plus. This dot data, I j, will equal math random, that's a number between 0 and 1, times 2 minus 1. So a random number between 0 and 2 minus 1 is -1 between -1 and +1. Good. Let's test it in our other file. So on M0, we can just go M0.random weights, and hopefully that should work. So currently that's what it looks like. Let's run it. There we go. Yep, that looks good. We've got some random weights, negatives, positives, and everything in between. Great. Head to our other file and let's create our next method, add to matrices. So we'll make this a static method. That just means we don't have to instantiate the class. We can just call it directly. We can go matrix.add. It will require two matrices, M0 and M1. We'll probably want to check that to make sure that they have the same dimension. So we can go, we'll create a new method, a new static method, matrix.checkDimensions. It will require M0 and M1. Let's create that now, actually. So check matrices have the same dimension. Same dimensions. So static check dimensions M0 and M1. If M0.rows doesn't equal M1.rows, or M0.cols doesn't equal M1.cols, then let's just throw a new error. Throw new error. The message we could, how about matrices are of different dimensions. Okay, so we check that. Now we'll need to create, in our add method, we'll need to create a new return matrix. So let M equal new matrix. The rows will just be the same as what's passed, so M0.rows, M0.columns. And we'll need to loop through each of those. So let I equal 0. I is less than M dot rows, I++. And another loop for let j equal 0. J is less than M dot cols, j++. What will we do here? So M dot data, I j will equal, I'll just copy that, M0 dot data ij plus M1 dot data ij. So we're just adding each individual cells together and assigning it to the new matrix. And we'll have to return that matrix, return M. Okay, let's test that in our other file. First, we need a couple of more matrices to test with. So let's create two more. M1, which will be 2 by 3, and just change up some of these numbers here. That will do. And M2 will be a different sized matrix, say 2 by 2. So let's just delete that. Okay, good. Let's try, we don't need to use this random weights anymore. Let's try to add M1 and M2. It shouldn't work because they're of they're of different dimensions. So matrix.add M1, M2. Let's try that. Error, matrices are of different dimensions. And that's on line 81. Yep, that's correct. How about we try to add M0, well, M0 and M1, they should add. We'll probably want to print out the data before we add them. M0 data, M1 data, and we'll print out this data. There we go. So we'll add that and show the data of the result matrix. Okay, so the first matrix, 2, 1, 1, 4, 3, 0, next matrix 0, 1, blah, blah, blah. So adding each of these, so 2 plus 0 equals 0. Sorry, 2 plus 0 equals 2. 4 plus 2 equals 6, that's right. 1 plus 1 equals 2. 3 plus minus 3 is 0. Minus 1 plus minus 1 is minus 2. And 0 plus 0, 0 plus 0 equals 0. Good, adding works. Head back to our other file. We also need to be able to subtract matrices. So it'll be very similar to adding. So just copy all of that, paste it down here. Subtract 2 matrices. Subtract. Almost identical, except that we just need to change this plus to a minus. So it'll be M0 data minus M1 data. So the order is important here. Let's test that. Right, so instead of adding M0 and M1, how about we subtract? Okay, so 2 minus 0 is 2, 4 minus 2 is 2, 1 minus 1 is 0, 3 minus minus 3 is 6, minus 1 minus 1 is 0, and 0 minus 0 is 0. Good, it looks like it's working. Just make sure the error checking is working okay. So M2 minus M1 should not work. There we go, error. Matrices are of different dimensions. Great. We also need to be able to multiply 2 matrices together. So in a similar way that we've subtracted them, let's set up a multiply 2 matrices. Multiply 2 matrices. Multiply. If you know anything about matrices, this is not the dot product. So just make a note, not the dot product. That's a separate thing. We'll need to do that too, but it's a different operation. It's just multiplying each cell by each cell. So all we have to do is change that minus there to a times. Head back and test it. So matrix multiply, multiply. M2 and M1 shouldn't work. Let's just make sure. Yep, it doesn't work. And M0 and M1 should work. Good. 2 times 0 is 0, 4 times 2 is 8, 1 times 1 is 1, 3 times minus 3 is minus 9, minus 1 times minus 1 is 1, 0 times 0 is 0. Looking good. Next, let's calculate the dot product. Let's create a function to calculate the dot product of 2 matrices. So dot product of 2 matrices. So static dot M0 and M1. Now, for 2 matrices to be dot compatible as such, the first one's columns must be the same as the second one's rows. For example, a 4 by 2 matrix and a 2 by 4 matrix, they're dot compatible. The inside numbers are the same. So for example, 3 by 2 and 2 by 1, they're compatible. So let's test for that. If m0.cols doesn't equal m1.rows, then we have to throw an error here. So throw new error. And the error message can just be matrices are not dot compatible. Okie dokie. Now the size of the resulting matrix, so let's create a new matrix here. Let M equal new matrix. The size of the resulting matrix is equal to the outside numbers. For example, 4 by 2 and 2 by 4, the resulting matrix will be a 4 by 4. 3 by 2 times a 2 by 1 would be a 3 by 1. So that'll be the m0.rows, and the number of columns will be the m1.cols. Right. Next we have to do the similar sort of loops that we've been doing in all of these. So for let I equals 0, I is less than the m.rows, I++, and for let j equals 0, j is less than the m cols, j++. So inside here is where we need to do our tricky stuff. Basically we need to multiply each cell of the first matrices row by each cell of the second matrices column, and then add up those products. I'll post a link below how to do this by hand if you're interested. So we'll need to create a variable called sum. Let sum equal 0. And another for loop. For let k equal 0. K is less than the inner number, which will be the m0.cols, k++. And then we'll have sum plus equals, so we'll continually add this together. Sum plus equals the m0 data, I, the ith row, and then the kth column, multiplied by the m1's data, and it will be the kth row. Remember, the inside numbers are what's matching them, by the jth column. I think that's right. Sum plus equals that. And then finally we need to set the ijth. So m.data I j will equal the sum. Okie dokie. And then finally we'll need to return that matrix. Return m. So let's test that out in our other file. So matrix dot m0 m1. Now m0 is a 2x3 matrix, m1's a 2x3 as well, so they're not dot compatible. Let's just prove that. Yep, error, matrices are not dot compatible. So which of these are dot compatible? Well, how about m2 times m1, so a 2x2 times a 2x3 is dot compatible because the inner numbers are the same. Let's just update this here. Give that a go. Right, so the first row entries times the second first column entries. So 1 times 0 is 0, plus -1 times 2 is -2. Yeah. The second one, so 1 times 1 is 1, plus -1 times -3 is +3, is +4 in total. Yep, looks like it's working fairly well. The next function that we'd like to do is to create some sort of conversion function to convert a regular array to a matrix. Because when we pass in our input data from our game into the neural network, we'll probably just pass it as a regular one-dimensional array. So, convert array to one-rowed matrix. So static convert array, we'll call it convert from array. We'll pass an array, and all we'll do is return a new matrix with one row. The columns will equal the array.length, and the data will just be the array itself. Okay, let's try that. First of all, let's create an array. So let array equal, just make an array of any length with some random numbers inside. We'll want to print that out to the console, so console log array. And we'll also want to print out the converted array, so using table. So matrix.convert from array, pass our array. And we'll want to see the data of that. Okay, oh, we don't want to see the rest of this stuff, so let's just comment that out. Let's give that a go. Incorrect data dimensions. Okay, something's gone wrong here. 25 in our matrix function. Where are we? So up the top here, page, line number 25. Okay, so we failed this data integrity check. I can see why, because it's checking the data.length. Now the length of a single dimensioned array is the total length, so it would be 4 in our case. but we don't want that. We want that to equal the rows, which is 1. So to get around that, all we have to do is create a two-dimensional array in our convert array. So convert from array, here we just need to put square brackets around that. So essentially we're putting an array inside of an array, a 2D array. Okay, let's give that a go. That's better. So our regular array, 4, 5, 6, 7, and our converted array to a matrix, 4, 5, 6, 7. So it's a 4-columned single row array. Great. Next, we'll need to create a function that can apply a function to each cell of the given matrix. So we'll call that map. So just down here, apply a function to each cell of the given matrix. The reason we need to do this is because in neural networks we'll be using a function called the sigmoid function, and we'll need to apply it to every cell. So let's create a static method, static map, which takes M0, a matrix, and a function. We'll just call that M function. And we'll need to create a new matrix. So let M equal new matrix. It'll be of the same size as the past. So M0.rows, M0.cols. We'll have to loop over in similar fashion to what we've done up here. So let I equal 0, I is less than M0 dot, well, M rows is okay too. M rows, I plus plus, J, yep. And inside here, all we need to do is go M data I j. M data I j will equal the function of that data. So the function of that of itself, effectively, M data I j. And then all we have to do is return that matrix. Hang on, we don't want to assign the M data because that's empty. We want to assign the M0 data, so the one that's been passed. So that data we want to apply the function to, and then we'll assign that result to our empty array, our empty matrix. Let's give that a go. We don't want to see that array anymore. So console table matrix.map. We want to map, let's just choose one of these arrays. So we'll choose M2 and let's apply a function. We can use what they call an arrow function. So that's just x equals greater than. It looks like an arrow pointing rightwards. And then we can just, what do we want to do to x? So x times 2. So that means we'll times every cell by 2. And also, let's copy this just above. Let's show the original table. Okay, let's give that a go. So the original table, 1 minus 1, 3, 0. 1 times 2 is 2, 3 times 2 is 6, and so on. That's working well. And one more function, so x divided by 2, say. So 0.5, 3 divided by 2 is 1.5, 0 divided, minus 1 divided by 2 is minus 0.5. Great, that's our map function handled. And the last function for today is to find the transpose of a matrix. Now, the transpose of a matrix is simply when we switch the columns with the rows and vice versa. So find the transpose of the given matrix. So a 4-1 matrix will become a 1-4 matrix. So static transpose, it'll just take a single matrix as its parameter. And basically we'll be doing something very similar to this. Just need to modify a few things. So let M equal new matrix. We need to switch the columns for the rows. And we need to make sure that we loop over the past matrix. So M0 rows, M0 columns. Now M data ij, we want M data ji. M data ji will equal M0 data ij. Let's test that out. Okay, so matrix.transpose. Let's transpose, say, matrix 1, so M1. And we'll just put the M1 data before it. Okay, so the original matrix is 0, 1, minus 1, and then the column down here is 0, 1, minus 1, 2, minus 3, 0, 2, minus 3, 0. So a 2, 3 matrix has become a 3, 2 matrix. Excellent! And that will do us for today. We've done lots and lots of matrix maths. Not very interesting, I know, but we do need it to create our neural network. So in the next tutorial, I'm hoping to get into the meat of the project and create the actual neural network itself. Okay, until next time, talk to you then. Bye!